I thought this would be an interesting video to make. Let's go over some low scoring questions and why I think they were low scoring. Some are quite obvious as to why they're low scoring, some are not, but I'll just my opinion. Pretty much stemming from the same weakness. But anyway, let's begin with this first one. We have this integral from 0 to 3, absolute value x minus 1 dx. We're giving us 5 choices. And only 25% of test takers, this should be test takers, got this question right in 1985. You can just change it to students, sorry, just changing this live. Okay. Now, why do I think most people did not score this correctly? By the way, there's 5 choices back then. So even randomly guessing is 20% chance of getting it right. So it looks like a little better than just by chance. Okay, so the average student probably panics because there's an absolute value in this integral and they're not comfortable working with absolute values. They probably use a calculator to graph it or something like that to try to get the answers in their homework and never bother to figure out how to think through it. That's what I did. So that's why I'm guessing, okay? So here is what an above average student would do, or how they would probably think of it. There's, of course, this, let me jump to this slide first, this long way of doing it, all by hand, where you first figure out that this absolute value function, if you don't have the absolute values, then x minus 1 is the linear function. It's negative when x is less than 1. Therefore, we want to tack on the negative 1 when x is less than 1, okay? So how does x minus 1 look? There's a y-intercept at negative 1, and there's a slope of 1, right? The x-intercept is at 1 as well, okay? At 1 comma 0. Okay, so this portion right here is negative. So we need to flip it to positive. That's why we tack on this negative 1 over here, okay? And then you go through the motions to get that the answer is 5/2, or the smarter way, quicker way to think about it is, first of all, integral is area under the curve, okay? And as I just explained, any part of the function that is negative, I need to make it positive because of the absolute value, okay? And we know, hopefully, how to sketch absolute valued functions. It's the V shape. In this case, the vertex is at 1 comma 0. The slope is 1 on one of the branches and negative 1 on the other branch, okay? So this is what it is on Desmos. I just pulled it there. So since integral is area under the curve, we can find this area over here. That's just a triangle. And it's up to 3 right over here. So we can find this area as well. It's another triangle. So you can just add up the area of the 2 triangles and get 5/2 as well. Okay, so issue number 1 from this problem is panic due to absolute values. You have to understand what's going on. Okay. Number 2 in the slide set, for these multi-choice problems, they're typically low scoring, especially if they're very conceptual. So this is probably why it was not so good scoring, okay? 25% of students got this right in 1985, okay? So let's see what it said. Let f and g have continuous first and second derivatives everywhere. If f of x is less than or equal to g of x for all real x, which of the following must be true? Choice 1, f prime is less than or equal to g prime for all x. F double prime less than or equal to g double prime for all x. Integral from 0 to 1, f of x dx less than or equal to integral from 0 to 1, g of x dx. Okay? So a lot of times with these types of problems, if you can think of a counter example for any one of the choices, 1, 2, or 3, any counter example, then you can cross it out and maybe you can eliminate some of the 5 choices, okay? Otherwise, you have to be able to prove that it's always true. Otherwise, you're making a guess, okay? So immediately, as I'm going through this, I'm already thinking 1 and 2 will be kind of hard to, at least right away. I need to do some more thinking probably. If they're true, they're kind of hard to prove. We only know that f is less than g, so the y values of f is always less than g. We don't know anything about the derivatives and second derivatives. We don't know anything about if f is increasing, decreasing, which is the first derivative. We don't know anything about f's concavity or the rate of change of the rate of change. That's the second derivative. So that's why I'm thinking 1 and 2 are kind of hard to prove. So maybe let's look at the third choice. All right, and we can actually think through that number 3 is always true. Why is that the case? First and foremost, concept number 1 I wrote over here, because they tell us that f and g have continuous first and second derivatives everywhere. If something's differentiable everywhere, that means it's continuous everywhere. Remember that important concept? If something's differentiable, it must be continuous. Okay, so that therefore f and g are continuous everywhere, first and foremost. Okay, why is that important? Well, we can think of now integral. Integral is area under the curve. So if f and g are continuous everywhere, then we are in good shape. We don't have like an infinite area, especially if you're in Calc BC, you know about improper integrals. Okay, so I'll just say that. Okay, so concept number 2, integrals area under the curve. Therefore, since we know f is less than g always, we can even draw a sketch. If f is always less than g, and integral is area under the curve, wouldn't the area under f always be less than the area under g? Always true. So we know that we need to pick 3. So what do? We eliminate A, B, and D right away. We eliminate half the choices, all right? Okay, so now to figure out if it's choice C or choice E, let's try to think of a counterexample for either 1 or 2. Can you think of one? Let's keep things simple. Usually, counterexamples are very typical or think easy. You don't need to overcomplicate, okay? A lot of the times, not always, but general rule of thumb. Try easy cases first, okay? Would you agree that f is always less than g if f is a constant minus 100, so somewhere down here, and g is sine of x, sine is up here? Yeah? So this is f, this is g. So what would f prime and g prime be? Well, f prime is a flat 0, and g prime is cosine. So is f prime always less than g prime per option 1 over here? No, because sometimes g prime is negative and f prime is 0. So that's a counterexample right there. So 1 cannot be true, and therefore e cannot be true as well. So e cannot be the choice, so the answer must be C. Okay. Again, these multi-option ones are typically low scoring, so not surprised with this one. Actually, it wasn't too bad. It was, what, 25% of students got it right? So not like a little better than randomly guessing, probably. Okay, next. The regions A, B, and C are bounded by the graph of the function f and the x-axis. If the area of each region is 2, what is the value of integral from -3 to 3, f of x plus 1 dx? So 23% of students got this right in 2003. And why do I think this is low scoring? Excuse me. Sorry. The average student probably is thinking, this problem I haven't really done before. It's not a procedural problem where it's like, take the derivative or implicitly differentiate, find the slope of the tangent line. Things that are very routine that you probably did a lot of practice on. This is not one of them, probably. So you panic, you give up, maybe. So the average, above average students would, of course, persist a little bit and start thinking, maybe this is testing properties of integrals. Okay. Now, how do we use properties of integrals here? We can split up this integral that they gave us as integral from -3 to 3 f of x dx plus integral from -3 to 3 of 1 dx, okay? So now we just evaluate the two pieces. What is the integral from -3 to 3 f of x dx? It's just the sine area of all the 3 regions, okay? Integral is area under the curve, the sine area, okay? So A is -2, B is above the axis, so it's +2, C is again below the x-axis, so it's -2. So integral from -3 to 3 f of x dx is -2, okay? Now integral from -3 to 3, 1 dx, now this portion over here, you can just fundamental theorem calculus. By the way, if you're going to take multivariable calculus, you should be very familiar with how to do these quickly is just 1, 3 minus -3 by the fundamental theory of calculus, okay? So then the answer is 4, which is choice C. All right. Next, 7% of students got this question right. There's a fatal error that over 90% of students made. This integral from 0 to 1, square of x squared minus 2x plus 1 dx, okay? So this is probably what the average student did. Just doing things procedurally without thinking, okay? They realize that the inside of the radical can be factored. Good. And then they just simply took the square root here and write it as x minus 1 dx. And then they evaluate, do fundamental theorem calculus, they get minus half. So they pick choice B. Here's the fatal error. This guy is always positive. The output of a square root must always be positive. So between 0 and 1, it's going to be somewhere up here above the x-axis. Shouldn't the area under that curve, which is the integral, be positive then? Why'd you submit a negative answer? So what went wrong? Okay, so that's mistake number 1 over here, just blindly doing it. And then number 2, they don't check their work and interpret, interpret their answer. Okay? The above average student would have caught that, and they would also know that I recall that when we square root x squared, for example, it is absolute value x. Sometimes you write it as plus or minus x. You're probably more familiar with that. Okay? So it's more precisely, it's absolute value x, okay? So instead of just x minus 1, it should be absolute value of x minus 1. And then when we evaluate that, this is exactly the same curve from the first problem, okay? So we can just find the area of this triangle over here, and it's half. Of course, C is the answer. Next, 27% of students got this question right. So a bug begins to crawl up a vertical wire at time t equals 0. The velocity v of the bug at time t for t between 0 and 8 is given by the function whose graph is shown. What is the total distance the bug traveled from t equals 0 to t equals 8? The misunderstanding that most students probably made is probably displacement versus distance traveled, total distance traveled. Okay, so the above average student would have understood that concept. Total distance is the absolute value of the integral of the absolute value of the velocity. Basically, you want to count every single movement. Okay? Even if you move backwards, you want to count that as well because you spent energy to move. Okay? If you like to think of it like that. Not to be confused with displacement, which is just the integral without the absolute value. And by the fundamental theorem of calculus, it's just s of 8 if s is the position minus s of 0. So notice displacement is the change in position. That's underlined. Displacement is change in position. Total distance traveled includes all movements. Displacement is just relative. Okay? Relative from where you started, how much you moved. Versus total distance is you count any forward movement, any backward movement as well. Okay, so with that understood, because we want the integral of the absolute value of velocity, we want to find the area under the curve, and any negative area, we may just make it positive, okay? So the answer is B. I'll let you pause and read through the slide yourself if you need to, okay? All right, next, let f be the function defined by f of x is x cubed plus x. If g of x is f inverse of x and g of 2 equals 1, what is the value of g prime of 2? So 18% of students got this correct, so a little bit worse than randomly guessing, or about there, okay? So the average student, this was me actually in the past, I forgot the formula for the derivative of an inverse function, so I'm doomed. I don't know how to answer this question. I can only randomly guess. This was actually me in the past, okay? So the above average student would go like, even if I don't remember the formula, I can derive it quickly because I remember where it comes from. This is where knowing where the derivations come from greatly helps. Like if you forget the derivative of tangent, you can just do the quotient rule on sine over cosine. If you don't remember the derivative of inverse sine, if you remember how to derive it, you can quickly do it as well. That's implicit differentiation. All right, okay, so how do we derive it? We have to first understand that inverses, if you plug one into the other, you'll just get back the independent variable x. This is the definition of inverses, okay? So if we differentiate from here with respect to x, the derivative of x is just 1 on the left-hand side. The derivative of the right-hand side, we need the chain rule. So f prime of g of x, g prime of x, okay? So to solve for g of x, which is the derivative of with respect to x of g, okay? I just wrote it like that because, well, g is f inverse. So this is the derivative of f inverse over here, okay? So that is 1 over f prime of g of x, all right? So to find g prime of 2, it is just 1 over f prime of g of 2. Okay, so that's 1 over f prime of 1, because they give us g of 2 is 1, okay? So what is f prime? We just do the power rule, and then we find that f prime of 1 is 4, so then g prime of 2 is 1/4. The answer is B. Okay, knowing how to derive the formulas is very helpful, even though you might not think it is. Okay, especially in, you have to know a lot of things for this test, right? So, but in case you forget, you could always get the formula yourself if you can't rely on your memory. All right. I believe this is the second to last one. The graph of the function f shown has horizontal tangents at x equals 3 and x equals 6. If g of x is integral from 0 to 2x f of t dt, what is the value of g prime of 3? 24% of students got this correct. Okay. Average student would probably think, why is there a function of x or even just a variable in the limits of integration? I'm going to panic now. I don't know what to do. Okay. The above average student, though, will think when there's a limit of a function of x, or even just x, that is a function of x, as a variable, a lot of the times we use fundamental theorem of calculus just from doing other problems before. Okay, if we're not just finding area under the curve, then it's probably something to do with fundamental theorem of calculus. Okay, I'm going to delete this because I have a duplicate thing over here. So again, something to do with fundamental theorem of calculus. Okay. Okay, so this is actually assessing that and also chain rule. Okay, because it's not the fundamental theorem of calculus tells us that the derivative of this guy is just f of x. But now instead of x, we have a function of x. So u is a function of x, or we can say u is u of x, okay? A function of x, okay? So we need to do f of u times du dx, okay? Basically, you plug in the bound times derivative of the lower bound, okay? So, sorry, not lower bound. You plug in the bound, upper bound, times derivative of the upper bound. And technically, the more general way, because sometimes you have a function of x at the bottom as well, the procedure per se is you plug in the upper bound times derivative of the upper bound minus plug in the lower bound times derivative of the lower bound. Okay, in this case, derivative of 0 is just 0, so that's why that term goes away. All right, I've done many videos on that before, so you can check it out on my channel. Okay, so anyway, g prime of x is f of 2x times 2. This is our chain rule, okay? So g prime of 3 is 2 times f of 6, 2 times 3. So we need 6 here, okay? So what is f of 6? We look at the graph. It is at -1, so the answer is -2, which is choice C. All right? Last problem. Population P of T of a species satisfies the logistic differential equation dP dt is P times 2 minus P over 5,000, where the initial population P of 0 equals 3,000, and T is the time in years. What is the limit as T approaches infinity? P of T, question mark. All right. So this looks like people just randomly guessed. 20% of students got this correct. So literally by chance, probably, okay? So the average student will probably go like, I don't remember the differential equation for a logistic growth model. And they give up very similar to the derivative of the inverse. They don't remember the formula, they give up. because they think they're doomed. Okay, it's important to know conceptually where that formula comes from. Then you can derive it yourself again. Okay, common themes that if you've noticed in this video. Okay, so the above average student will understand and remember that logistic growth, first of all, remember has the term carrying capacity, if we call it M. That means, if you remember, it asymptotically grows to that carrying capacity, okay? In the real world, there's limited resources, so that's probably why, okay? And that the logistic growth, the differential equation for it, so the actual growth, is proportional to the current population and the remaining carrying capacity, M minus P. Okay, if M is carrying capacity, the maximum that the land can handle or something like that, and P is the current population, is the remaining that it can support, right? That's why I called it remaining carrying capacity, okay? So the differential equation has this form, K, because it's directly proportional, times P times M minus P, okay? And you might remember this, you sometimes work with it in this factored form where that M minus P, you factor out the M, so it becomes 1 minus P over M, so the carrying capacity is at the bottom now. Carrying capacity, okay? So, in this problem, first and foremost, we have to understand that this is just the carrying capacity, as I explained. P is the population, it's a logistic growth, so it's going to keep growing, but it's going to grow logarithmically. That's what logistic differential equation, and it's going to have an asymptote, okay? Actually, a log keeps going to infinity, right? So not quite like that. So my bad, I take that back. But it looks like a log, but there is a asymptote there. All right, so we just need to get that into the 1 minus P over M form. So we just factor out the 2, and there's our carrying capacity, 10,000. Okay. So to recap, hopefully these problems themselves were helpful, but what is some takeaways to get you into the top 20% and for sure get you the 5 on the exam? Understand the concepts. Like integral is area under the curve. We know how to sketch absolute value, so that's not too bad actually. This one, what's my tip for this one? Think of counter examples and pick easy cases for counter examples, okay? This one you got to actually think through. Just because you haven't seen the problem before doesn't mean you don't know how to do it, okay? That's a very common complaint I get from students who are average students. That's why I categorized it like that, okay? And then this one, check your answer. Make sure it makes sense first and foremost, okay? This one, know the concepts. In this case, displacement versus distance traveled. This one, if you don't know the formula, you can, if you understand where it comes from, you can derive it. That's the same as the logistic growth one as well. Okay? This one, take from experience. When you have a limit of integration that is a function of x, a lot of times we do fundamental theorem of calculus. All right? Hopefully this helps. Please like this video if it has helped you in any way, and hopefully I'll see you in another video as well. Bye.